Alright, so let's finish up chapter 2. Last time we saw a video on how to improve your vertical jump, and that was because of the stretch-shortening cycle. So sequencing and timing of contractions can be enhanced or enhance the total amount of force produced. So when a muscle is suddenly stretched, resulting in an eccentric contraction that is followed by a concentric, so think about when you're ready to jump, so you're going to stretch and then boom, take off of the same muscle. So you stretch the quads, you stretch the hamstrings. The total force generated in the concentric contraction is greater than that of an isolated right? So if you were just standing there and you tried to jump versus if you squat down a little bit, stretch, and then bam, take off, then it's much better. So just think about basketball, think about vertical jump, think about how you would touch the rim. You're just trying to stand there and just go straight up, or would you bend down a little bit and then boom, or box jumps, right? Functions by integration of the GTO and the muscle spindle. So that's how it works. So elastic energy is stored during the eccentric stretch phase, transition, and utilized in the concentric contraction phase. So stretch reflex is elicited in the eccentric phase of the motion, which subsequently increases the activation of the muscle that was stretched, resulting in a more forceful concentric contraction. So you know the concept, and now you understand the physiology behind it. So to be effective, the transition phase must be immediate, or the potential energy gained in the eccentric phase will be lost as heat. So meaning if you squat down, you can't just stay down there and say, well, I may jump, not jump. You got to squat and then boom, jump right up. So shorter the transition phase, the more effective the force production. That's the basis of plyometric training. So you want to increase your vertical jump, add plyometric training. Example, when a jumper moves quickly toward immediately prior to jumping upward, resulting in greater jumping height. So there's a lot of plyo drills that you can incorporate into your training with athletes. Antagonist muscle groups must relax and lengthen when the agonist muscle group contracts. So this reciprocal innervation effect occurs through reciprocal inhibition of the antagonist. Activation of motor units of the agonist causes a reciprocal neural inhibition of the motor units of the antagonist. This reduction in neural activity of the antagonist allows them to subsequently lengthen under less tension. So when you're squatting down and the quads stretch, well, the hamstrings have to inhibit, otherwise what's going to happen is you're not going to get anywhere. So they have to have reciprocal inhibition or innervation. So let's do an example. Compare the ease of stretching hamstrings when simultaneously contracting the quadriceps. Okay? Stretching hamstrings without contracting the quadriceps. So think about this. Next time you say that your hamstrings are tight and you're trying to stretch and your patient just says, oh, totally relax, totally relax. Instead, ask them to contract their quads. Right? Contract their quads, and you'll see that their hamstring length will improve. Okay, so that's a way to trick the brain. Now let's look at the angle of pull. Angle between the line of pull of the muscle and the bone in which it inserts, which is the angle toward the joint. With every degree of joint motion, the angle of pull changes. So joint movements and insertion angles involve mostly small angles of pull. So angle of pull decreases as the bone moves away from its anatomical position through the local muscle group's contraction. The range of movement depends on the type of joint and bony structure. Most muscles work at angles of less than 50 degrees, and the amount of muscular force needed to cause joint movement is affected by the angle of pull. Okay? So rotary component or vertical component of muscular force that acts perpendicular to the long axis bone or lever. So here's the rotary, here's the angle of pull, which is 90 degrees right here. So when the line of muscle force is at 90 degrees, so you look at this bicep tendon, to the bone in which it attaches, all the muscular force is rotary force. That is 100% of the force is contributing to movement. So boom, boom, 100%. All the force is being used to rotate the lever about its axis, which is right here. The closer the angle of pull to 90 degrees, the greater the rotary component. Okay, so that's why you watch American Ninja Warriors, they say maintain those L's, right? When you're rock climbing, maintain those L's. So close to the angle pulled in 90 degrees, the greater the rotary component. At all other degrees of angle of pull, one of the other two components of force are operating in addition to the rotary component. Rotary component continues with less force to rotate the lever about its axis. So second force component is the horizontal or non-rotary component and is either a stabilizing component or a dislocating component, depending on whether the angle of pull is less than or greater than 90 degrees. And I'll show you a video of this so the angle of pull makes sense. Again, if the angle of pull is less than 90 degrees, the force is a stabilizing force because its pull directs the bone toward the joint axis. Okay. Now if the angle is greater than 90 degrees, the force is dislocating, not dislocating in the sense that the bone's going to dislocate. That's because its pull directs the bone away from the joint axis. So sometimes it is desirable to begin with the angle of pull at 90 degrees, right? Chin-ups and pull-ups, I gave you that example. Angle makes the chin-up easier because of the more advantageous angle of pull. Compensate for lack of efficient strength. So again, if you want everything to be efficient, you got to understand mechanics, you got to understand anatomy and how everything works. And then it's easy. But what happens is when you start cheating the system or you lack strength somewhere else, then it's difficult. So that's why I was telling you in rock climbing, if you maintain those L's, so the angle makes the chin up easier, then you're good. But you see when people get tired, they don't maintain those L's and they'll just hang out on their ligaments and joints and then they'll fall eventually. Uniarticular muscles, they cross and act directly only on the joint that they cross. Example, brachialis, which can only pull the humerus and ulna closer together. Those are uniarticular muscles. Biarticular muscles cross and act on two different joints. Depending on certain factors, biarticular muscles may contract and cause motion at one or the other. So the two advantages over uniarticular: it can cause and slash or control motion at more than one joint. So your hamstrings, your biceps are biarticular, are able to maintain a relatively constant length due to shortening at one joint and lengthening at another joint. Muscle does not actually shorten in one joint and lengthen at the other. Concentric shortening of the muscle to move one joint is offset by the motion of the other joint, which moves its attachment of the muscle further away. This maintenance of a relatively constant length results in the muscle being able to continue its exertion of force. So let's look at this. The hip and knee biarticular muscles. Concurrent movement patterns occur when the knee and hip extend at the same time. So you're going to get the hip to extend and the knee to extend. If only the knee were to extend, the rectus femoris would shorten and its ability to exert force similar to the other quadriceps muscle would decrease, and its relative length and subsequent force production capability are maintained due to its relative lengthening at the hip joint during extension. So really what it's telling you is that in order to do a squat effectively, the knee and the hip, it must extend at the same time to exert a force. And you're thinking, well, of course, Patel, that makes sense. You're not going to be able to just extend this back or this without doing a squat. But you'll see people compensate, and you'll see some people do some crazy looking squats. I mean, it's just unreal. The squat is a great way to determine how bad of a shape you really are, because some people just, you go to the gym and see people squat, it's bad. So the hip and knee biarticular muscles, countercurrent movement pattern occurs in kicking. During the lower extremity forward movement phase, the rectus femoris concentrically contracts to flex the hip and extend the knee. These two movements, when combined, increase the tension or stretch of the hamstring muscles both at the knee and hip. So when you're trying to kick a ball, right, you got to flex the hip, extend the knee, so you exert more force. Right? So there are ways that these muscles work together. So the bottom line is, when you're training somebody for sport, you can't just isolate and do these exercises that just isolate these movements, and you're not going to be able to get effective goals or treatment that way. You got to look at the pattern and treat the muscles in those patterns. Multiarticular muscles act on 3 or more joints due to the line of pull between their origin and insertion crossing multiple joints. Principles relative to biarticular muscles apply to multiarticular. So, as a muscle shortens, its ability to exert force diminishes. So let's just look at the bicep curl. If you're already flexed max, you're not going to be able to exert as much force. So that's called active insufficiency. It is reached when the muscle becomes too shortened to the point that it cannot generate or maintain active tension. The muscle cannot shorten any further, so it cannot exert much force. Passive insufficiency is reached when the opposing muscle becomes stretched to the point where it can no longer lengthen and allow movement. So, easily observed in either biarticular or multiarticular muscles when the full range of motion is attempted in all joints crossing by the muscle. So look at this. So here's the rectus femoris, right? Rectus femoris contracts concentrically to both flex the hip and extend the knee. So that's your quads. It can flex the hip and extend the knee, but can completely perform either action at one at a time, but actively inefficient to obtain full range of motion at both joints simultaneously. Concurrent movement pattern. Okay, so this is possible, but when you try to flex the hip and extend the knee, you're really not exerting a lot of force right here. Okay, so if you ever watch kickboxers or Muay Thai, you can generate more force this way versus this way. Similarly, hamstrings cannot usually stretch enough to allow both maximal hip flexion and maximal knee extension because of passive insufficiency. That's why your hamstrings are tight. As a result, it is virtually impossible to actively extend the knee fully when beginning with the hip fully flexed, or vice versa. So a lot of times you just don't know how to stretch your hamstrings because you're using passive insufficiency. Alright, so let's take a look at some stretches.